Welcome to your AI Injection, the podcast where we discuss state-of-the-art techniques in artificial intelligence with a focus on how these capabilities are used to transform organizations, making them more efficient, impactful, and successful. Welcome back to the newest episode of your AI Injection podcast. My name is Deep Dillon. I'm your host and a data scientist at Xyonix. This week's topic is an important one. We have our regular data scientists, Karsten and Bill, back to discuss mitigating societal bias in AI. So, Bill, do you want to quickly introduce yourself, and then Karsten, and then we'll dig in?
Sure, I'm Bill Constantine. I'm a data scientist. I guess I've been doing this line of work for about 20 years now or so. And yeah, this is a really cool topic. So I'm excited to talk about it.
Awesome. Karsten.
Hi, I'm Karsten Tusk. I'm a co-founder at Xyonix. I'm a computer scientist that's been working in machine learning and AI for the last 20 years. And I'm going to be talking a little bit about societal bias in AI today.
Cool. So let's kick it off. And I'm sure as many of us know, the stakes of AI models to make decisions fairly could never be higher. And yet there are many high-profile examples where AI has been shown to give us unfair, inequitable, and sometimes exclusive decisions. So Bill, can you start us off by telling us what we mean when we say that AI can be affected by societal bias, and maybe start out by giving us a story of one of these AI gone bad examples?
Yeah, there's quite a few out there. So I'm thinking about the ones that are truly impactful. And quite some time ago, there was so societal bias is things like racism and sexism and gender bias and ageism creeping into your models in a way that harms people whose decisions could be affecting their lives, not just making them feel bad or divided. And so, yeah, there's lots of areas where this has reared its ugly heads. Its ugly head, rather. One of the things that comes to mind is there was a program a while ago called COMPASS. It stands for Correctional Offender Management Profiling for Alternative Sanctions. But basically, it was the idea was, could we develop some sort of AI models to predict whether somebody would be recidivist, which means that they, having had committed some sort of crime, what was the likelihood that they were going to commit a crime in the future, or be a violent offender and so forth.
Kind of a Minority Report sort of situation.
Yeah, exactly. Little Tom Cruise action.
Yeah.
For those who were in the 80s. So I think, so when I first read this article, it was really striking. There was an African-American gal who had stolen a bike, and she ended up, getting caught, and the police booked her. And sort of in that same county, along the same lines, there was a white guy that had been caught for breaking into, I think, businesses and stealing stuff. The African American gal was kind of like a one-time thing, and the white guy was like a career criminal.
Yeah.
And what they faced was being basically ranked for recidivist activity in the future, or were they likely to commit a crime in the future? And the African American gal got ranked really highly as being somebody that would commit a crime, and I think it was even a violent crime, whereas the white guy was like, yeah, he actually ranked quite low. So fast forward a couple of years, how did it turn out? Well, it turns out that the white guy ended up in prison for continuing to be a thief, and the African American gal essentially never did it again. Had this been, a one-off sort of thing, that would have been maybe just a sad exception. But it turns out there were quite a few of these that were going on, and they found out that the bias towards and against Black people was very high and profoundly wrong. That's the main issue, profoundly wrong in terms of its prediction. Now, keep in mind that this isn't just the police force using this they don't really have knowledge of what's behind the algorithms. There's also the judges. So people will come up in front of a judge, they would say, here's, John Smith and blah, blah, blah. And they would see basically what's the risk of this guy being a violent criminal. And if it had you as like, yeah, there's like, an 85% chance it had actually affected the judge's decision on how to punish them. Sometimes people served longer sentences. Sometimes maybe in cases where they could have gotten help or something, they didn't get it. So imagine the impact on these folks, these poor folks' lives,
Yeah.
This is definitely a situation where AI has gone bad, and a bias that was somehow caught up in that data ended up
Cool.
really adversely affecting them.
I'm going to rattle off a few other ones. So there's, there was some rampant racism in some software used by U.S. hospitals to allocate healthcare for, 200 million plus patients every year. There was significant bias against women by an AI gone bad in Amazon's kind of early attempts to build a resume filtering tool. There was the very infamous Twitter bot developed by Microsoft that went on misogynistic, racist, and Nazi-supporting rants. That was, a problem. There was a lot of gender bias and kind of some standard natural language processing tools that's been detected. Everyone's heard about face detection algorithms and significantly higher kind of misidentification rates depending on parts of the data that had kind of less training representation for particular races and gender. So I guess the big question here is like, not everyone's maybe machine learning AI folks who can kind of guess like what happened in all these cases, but I don't know, Carson, you want to maybe like talk us through maybe like the Twitter bot or any of these cases, or even just kind of in general, but like what's going on that causes us to like look at the output of these things and sort of see this sort of very, obviously kind of societal bias sort of scenario making its way into the bot?
Well, on the one hand, I think it's just people making bad decisions on what data to pick. For example, if you look at the hospital racial bias, it was about people who self-identified as Black that were generally assigned lower risk scores than equally sick white people, and it was about handing out memberships to special programs for people that need it, right? And so, because the equally sick white people were esteemed a greater risk, they got the memberships and kind of discriminated against the Black folks. And the problem was that they picked the total healthcare cost accrued in 1 year as a basis to figure out how sick the patients were. So in other words, if you spend a lot on healthcare during that year, you must have been sicker than the person that didn't. This is actually not a racial discrimination, really. It's a discrimination for poor people, and of course, that brings race into play. But it was a bad choice. It was just a bad choice of a metric to make that determination, and that's what was reflected in the model later on. And then
access to healthcare was not part of that, right? And
no, just money spent in total healthcare costs accrued in a year.
Bad variable.
Yeah, exactly. Somebody didn't think about why would you include that in this choice. It really has nothing to. It was a bad metric or bad representation for your state of health. Mm-hmm. So, but it was one of the data points you have, and sometimes people just look at, they don't really think about the data they have, to just take all the data they have and throw it into a model. And oh, great, the model does something meaningful and predicts something. But machine learning models have a very strong garbage in, garbage out principle, and you got to be really careful there. So
yeah, all of us have heard the stories of, and most of us have even been this person where, you're a grad student, you're completely, focused on your particular problem. And you realize, like, I don't know if it's, let's say it's, people detection or face detection or something. You try to get your corpus or your collection of data to train and evaluate on, and maybe it doesn't exist. And then you have to create it. Most data scientists tend to be pretty, like, this isn't the most important thing to them. They just want their data and then they want to move on. So they don't always think, very kind of heavily and deeply about the data sets. And so then just the sort of, happenstance bias of how they put together their data set can, of course, ripple into the algorithms. I mean, one thing that I've noticed a lot is a lot of times machine learning models get developed on kind of one data set, but then they get sort of applied maybe in different areas, or like in areas that were sort of, nobody ever really took the time and effort to ensure kind of fair representation in the training data used to train and evaluate the models. Bill, is that what you're seeing, when you study some of these systems?
I think so, and that actually speaks to the problem with the Amazon hiring system. They wanted to they basically were like, everybody wanted to work for Amazon, so they had, 100 resumes. They wanted to be able to take, or 1,000 resumes. They wanted to be able to rank the top 5 of those resumes automatically and then hire those people. But they turned out it was very, very biased against women. In fact, if there was an entry where you had something like, well, I belong to a women's rowing team or something like that, they were actually downgraded. There you have a situation where the population is very, very disproportionate. Most of the people that were applied to Amazon as, say, engineers and so forth were mainly male, and they didn't have much representation for females. And so they tried to offset that by taking out gender completely, but that didn't seem to fix it. And so finally, I think they just gave up on it after it got some negative coverage. And Amazon always claimed actually that human resources only use it as a guide and not a sole determiner of whether somebody get hired or not. But I don't think in that case that population was necessarily a lesser population of women who applied was necessarily represented fairly in that case.
So what's the right thing to do, or the right way to think about it? I mean, we all know that, well, maybe not all of us, actually, some of our listeners might not realize this, but like, if you've got a machine learning algorithm and you've got trying to categorize something into, let's say, one of, 2 buckets, and you've got, like 90% of your training data from bucket 1 and 10% from bucket 2, you kind of create a scenario where the model might be, inherently biased towards bucket 1. That might be perfectly fine and okay, and it might not be. So I don't know, Carson, do you have any thoughts on, like, because there's bias is sort of normal in machine learning. I'm not talking about societal bias necessarily, but just bias period. So how do you think about organizing, like balancing your classes and categories in a scenario like Bill's bringing up?
Well, the problem is that you're not actually balancing your target classes here, right? It's not that you have men and women and you're trying to classify the resumes into male and female. Uh-huh. It's kind of like you have men and women represented in your data set. They have differing attributes, but what you're trying to predict is whether or not they will be a good hire. And now your minority class is actually it's not one of your targeting classes, right? But the distribution in your training set is such that a certain class is underrepresented there. And if you get even unluckier, that class that is underrepresented there has bad attributes. So let's say in their data set, it's Amazon from the last 10 years, highly male-dominated tech industry. Maybe the 20 women they had were actually pretty bad. I'm not saying they were, I'm just making that up. So what does the model learn? No, the model simply learns woman makes a bad employee. Great. And there's your bias, right? And there's literally nothing you can do about it if you have a bad data set to start with. Or if you're trying to do something where you have it's the reality, right? In our training sets, minority classes are minorities. And it's really hard to fix that. Sometimes you can consciously doctor the attributes so that everything that kind of like identifies the minority class is excluded from the data set, but that's not always possible, as we've seen in the Amazon data set, right? They removed gender, but still there's attributes in your resume that differ between men and women, but you can still say, hey, that was a woman.
But you could, for example, balance by the target in this case. So you could say, okay, well, look, our goal is that we want to have, 50%, whatever, 50-50 on the hiring front. So the data we're going to include is going to include 50% good female hires, 50% good male hires, 50% bad female hires, 50% bad.
You could try that if you had the data, but if you had that data, then you wouldn't have the problem in the first place. because most of the bias, if not all of the bias, is based on unbalanced training input data sets. You see
But
that
you
in
could
the
toss some data, right? Or you could oversample or undersample.
not if you don't have it. And if it's really highly unbalanced, if you have 100 female hires compared to 10,000, all your oversampling in the world wouldn't help you, because it's just not enough. You can't fix extreme imbalances. So it's a problem.
You're listening to Your AI Injection, brought to you by Xyonix.com. That's Xyonix.com. Check out our website for more content, or if you need help injecting AI into your organization. Bill,
So
what
one of the
are
things,
your thoughts there?
yeah, it's interesting. I think I liked what Carsten said in the fact that, you know, even if, say, you have a minority class that also is ill represented, then you're so hosed, right? It's not just that you have
Just for the listeners' sake, when we say minority class, we're not talking about racial or ethnic things. It's just a machine learning lingo where, like, let's say, you know, we're talking about percentage male, percentage female. If one is 51%, one's 49, the minority class is the one with 49%.
Yeah, that's right.
Yeah,
we're only
sorry,
talking about count. We're only talking about counts of classes in your data. Yeah.
Yeah.
But, you know, so IBM has an initiative out where they're trying to offset societal bias, and I'm hoping, and I'm jumping ahead in the conversation.
No, take us there. Take us there. Let's talk about the mitigation strategies that are out there.
So they have a suite of tools they offer. It's called the IBM's AI Fairness 360. It's an open source toolkit. It's available in common languages that we use for dealing with machine learning. And so it's their first sort of I think their approach, and they've taken it quite seriously, which kudos to them for doing so. They have sort of 3 attacks at trying to adjust for the unfairness in AI bias. So one of them involved in the pre-processing stage. And that's where they take training data and labels that may be transformed or modified or weighted to somehow try to promote fairness during subsequent training. So Deep, you mentioned maybe we could try to form a more balanced training data set if you have that, right? If you have that, like Carsten said, if you have that available, then maybe you could try to form your models making a more balanced data set. They apparently have tools for in-process stage, so when you're actually training the models. They have tools for adapting for fairness, like, for example, adding a discrimination-aware regularization term in the loss function. So what that means to the regular folks is when we train these models, we have this thing called the loss function, which accumulates error, and then it iterates over and over again, tries to reduce that error. Well, if you know that you're discriminating against a particular class of folks, you might make that error super pronounced. Like in the case of our original idea about Black people being unfairly projected to create crimes in the future, or to perform crime in the future, you have a test holdout set that basically says, you know, that's actually not true. So every time you mess up there, make it a huge error.
I have a bit of a problem with that, but we can come back to that later, because what if the model is actually right? You know, we're all against bias and against racial bias, etc., etc. But what if that discrimination or that is actually the correct choice because it's true? But we can talk about that in a bit. It's a little bit of a controversial topic.
It is a controversial topic, and I totally agree. From a machine learning perspective, you don't want to elevate error unless it's incorrect, right? This is a really bad error. It's actually not a reflection of what we see in the real world.
So, Bill, going back to the IBM tool for a second, because I didn't quite understand that. Can you explain to me, what exactly is explain that to me again. I didn't quite follow. Like, what exactly is the tool trying to do here and enable?
So the toolkit is a bunch of things. So first of all, they develop a bunch of fairness metrics to say, that you can apply these metrics to be able to detect whether your algorithm or your data that you're using may have biases in it itself. So they have sort of basic things like for example, when you have a group that is so-called privileged or not privileged, maybe looking to get a loan from a bank or so forth, is the ratio of positive outcomes in a certain class the same between, say, white folks and black folks? If there's
So you have to define those criterion somehow.
You do, right.
Somehow in there, you have to go out of your way and say like, hey, we want 50. This is akin to what I was sort of suggesting earlier with the target variables, basically saying, okay, we want 50% of the hires to be women and 50% to be men, or whatever the gender distribution is across non-binary, et cetera. So, okay, so that makes sense to me.
Oh, wait, there's one more thing. Outside, they also basically asked that there's another, it's a post-processing stage where the predictions are themselves altered in order to make them more fair. So basically throwing away what the AI model is predicting or suggesting and doing something that's more fair and equitable towards folks that are being discriminated against. So that's a general approach, but there's tools out there that us data scientists can use to try to mitigate these.
I mean, one of the things that comes to mind here is like, if you kind of jump up a level, like what this tool and what we've been talking about, there's kind of a common theme, which is sort of like the theme of visibility. Is the potential societal bias visible to those working on the problem? If they're not even looking for it or paying attention to it, then they're most likely not going to find it or notice it. And so it feels like a key part of this is just simply asking the question, like, what could happen here? So like the example that I'm sure everybody's done this at some point or other. If you just go to Google image search, and certainly in the late 90s and mid 90s to now, it's improved. But if you just search for something like, beautiful person, beautiful woman, beautiful man, you're going to get like racial bias, coming back for sure. And so then the question is like, if you're making that thing, you should probably sit down and like think about that. And like, what is it actually, like, what is the right thing to do there is a separate question from like, what is the thing that could actually happen here? So my question is like, what can a team do that's working on a problem where somebody has an intuition that there might be some bias here? So, I mean, it could be, it could be as sort of benign as like, like a project that I worked on a few years ago was, we were just trying to take video footage from like this kind of social streaming app and just automatically pick out the quote best picture, like the moment in the video that was kind of really essential. And so as a part of that, we ended up running a lot of mechanical Turk experiments to sort of, get data and figure out like, given a, like what was kind of the most important. And part of the ingredients came down to like what people wanted to look at. And so, the original example was like kids hitting a ball on a tee, and you want to capture the moment right before the bat hits or right after the bat hits and the ball is moving. But in other cases, it was like, you've got, a group of, you've got maybe a video scrolling through like, a few different people, and it's got to pick out, well, what's the best shot? Is it the one where you've got like the most distinct kind of facial expressions? Is it the one that's got the really good looking, person, or the really goofy pose? This all comes down to kind of like human nature, human choices. Like in that kind of a context, I don't know, like what would you suggest the team actually do and pay attention to?
Give up.
Give up.
Just plain give up. Because the scenario that you're describing is one where bias is ultimately inherently defined in your problem. For example, in your video scene, let's say, well, I don't know what is the best shot, right? There's no absolute truth here. This is not the laws of physics. So we cannot really look up what is the best shot. It's a matter of opinion. And so the best thing you could do is you can take 1 million people and ask them this video, what is the best shot? And now 70% of them will tell you, this is the best image. Now, if you say, okay, these 70% are right, I'm going to cater to them. Now you have basically discriminated against the remaining 30% that hated that shot. And so now you have created your own two groups and you're discriminating against the minority group that is not following the majority opinion. So in that scenario, give up. You can't do it. You can only go by majority, and that's hopefully a good thing. Hopefully you have adequately measured, the population's taste.
Well, I mean, that seems really simplistic to me. Like you could create cohorts of your population, and within the cohort that has the majority opinion, that could be one approach. But there might be like a handful of others. Maybe there's a cohort that's really interested in the action shot, the other one that's like the people shot. I mean, it feels like you could pursue a population-centric optimization strategy.
And then how do you regulate that? Do you 60% of the time you go with the 60% population to satisfy them, 20% with the action shot, 5% with the black image, 1% with the green floor? I mean, where do you buy in?
Well,
do you want to sample it according to population preference? Because that's actually what the model would be doing automatically, really, kind of, if it distributes it according to that source population. I feel like if you want to address the whole bias problem, you need to identify what possible bias exists beforehand, and then train your models accordingly. For example, in the gender bias, maybe you have two different. If your goal is really to have a 50% male and 50% female hiring rate, then split the candidates into by gender in the first place. Have two models, one model that picks the best male candidate, one model that picks the best female candidate, and just go down a ranked list on each side until you have a 50% hiring rate. Split it up beforehand and don't let the gender bias creep into your model, because all you're going to do is ruin what the model is trying to do best, which is predict the actual outcome. Because the adjustment for societal bias is something that is sometimes contradictory with your target variable, and in my opinion, you shouldn't do it. If you want to be fair, then be fair, but rank each group, separate them, and then rank them. Don't mix them together.
That's an interesting approach, Bill.
Yeah, I do think it's a good approach. I think it's probably worth saying, and Carsten, you had alluded to this earlier in your thoughts when we're talking about the Amazon experiment gone awry. I think it's also, I mean, you can do some due diligence in your data collection deep, especially when you have something that's subjective, like say you're building a model to say who's pretty or who's handsome or who's not. Maybe you do, the people that are actually labeling that data, maybe you do your due diligence to make sure that they're from lots of different locations, ethnicities, countries, language, ages, genders, so that the population that you serve, which is all of those folks, aren't being singled out as being ugly or beautiful, And you talk about, there's the human element of this that we really have to take into consideration. If you're looking at what's the best video shot, blah, blah, blah. Well, I mean, who really gives, if you're talking about somebody who's good looking, like a teenager, it could very much affect them in their self-esteem. And, so it's very, very important to at least understand, like, do the best you can to understand, like, where is this data coming from? Is it labeled unfairly, actually? So maybe that's my source. I could help mitigate that by making it more fair. And then, you know what? If it's coming up with something that it is, regardless of if it's, say, accurate or not, if it's discriminating against the population, do something about it, right? I mean, you don't have to necessarily rely solely on the model predictions.
Yeah, I mean, it feels to me like a lot of what I see is, so, you've got a company that is making a business decision to address a particular market, and then they attract a particular population of user that has particular kind of attributes on, let's say, day 1 to 90 or something. They release a model, and then all of a sudden it kind of shifts. So like, to take the beauty example, I don't know, maybe it's like a Tinder-like app or something. But if you're like, from a business context, let's say you're you're trying to assess something as like obviously, you know, problematic as this, but you could start off like nation by nation. Like you could start off in Botswana at first, and now you've got like like an incredibly tiny minority of you know native Botswanan folks in the imagery. So you don't have, you know, white folks represented or Asian folks represented or whatever. And you could, you know, you could satisfy that market, and then you could kind of walk out to a completely different nation, you know, and then you have like multicultural societies like the US where you might sort of say, I'm going to take the natural, let's say, ethnic population distribution, and then for each of those things, try to ensure representation in the ground truth in the training data. I mean, it seems like A, we've honed in on the fact that this is hard at, and B, that you have to pay attention to even know that something's a potential problem. So that alone feels like a win to me, because you're forced to ask the hard questions. You're forced to like rearrange and maybe do something like Carson's suggesting, where you build a, you know, a female only like qualification assessor, and then a male only qualification assessor. So it feels like just getting the conversations into teams early on, and having the kind of awareness is kind of part of the solution. You mentioned provenance, like just kind of knowing where data is coming from. That seems important, because a lot of times someone just hits import, you know, or maybe they wrote a script, they import, and then boom, there's 15 million whatevers, images, you know, documents, et cetera, like suddenly in their corpus or collection. If they're not thinking about where those 15 million came from, maybe they came from like some constraint, like Carson was pointing out, you know, earlier in our conversation. Maybe they're coming from a, you know, a corpus that's got an inherent bias. It seems like maintaining that provenance, knowing what came in, and knowing what the biases of the source are, simply tracking that stuff feels valuable to me.
I agree. And I just want to, I think the real danger here is that these tools are not just being used by data scientists. They're being used by people who have a blind trust in them that they're telling them the truth. I saw a news piece a couple of weeks ago where a Black man walking down the street was identified, and they, you know, somehow had some sort of visual facial recognition, going back to the face recognition thing, that you know, we have this word from our computers back in the base that says you are this person. He said, well, I'm not that person.
Check
Where's
my
your
ID.
Where's your license? Well, I don't have it. I'm just walking to the store.
Yeah.
Okay, well, I'm sorry, sir, we're gonna have to detain you. He's like, you got the wrong guy. You got the wrong guy. Well, the answer was, well, this is telling me that's not the case. You know, and they have no clue of how accurate that model is. They have no clue of the provenance of that data, you know, accuracy of that data, whether it's biased or not, and so forth. That's the real danger. In fact, the Seattle is a part of King County, banned facial recognition. And I think San Francisco had done that a couple of years ago for this very problem. So yeah, it's a very tough problem. And I have one more comment that has to do with.
But just I want to like before you move on, I want to address that point. I think, you know, like they did dig into that case, I believe, and they found that you know, African American male imagery was significantly underrepresented in the, you know, in the data set for generating you know, facial identification relative to its population, to the population. And so the, you know, I feel like a key part of this is when we're talking about stuff that has that significant of societal impact, somewhere in this conversation should be transparency around the collections and the documents and data that's used to generate these models, so that people can like sort of point out some of these obvious biases that are going to result.
And I think that's one of the big problems. You know, after all, we call it AI, but really most of modern AI is pattern recognition, right? It's statistical learning, pattern recognition. There's very little reasoning or anything like that in it. And so it really only learns what it sees, and our society is inherently biased, right? And so if I have a model and I show it basically a population and trying to figure out criminals, and I have a population of, let's say, 50% red, 50% green, but in the red party, only 20% are criminals, and the green party, 50% are criminals, well, then automatically green is associated with being a criminal, just from a statistical perspective, right? A much higher likelihood.
Yep.
And as long as we train our models on real but biased data, that is not going to go away. And so, like you said earlier, I think the best thing we can do is be aware of bias, be aware that bias comes from data, identify it in the data, try to balance it if we can. And in a post-mortem step, look at the output of the model and see if it shows any signs of bias. And if it does, well, go back to the input and see if you can fix it. What I do not believe is kind of like this in the middle approach, try to like train models that are not biased, because by doing that, you introduce something into the model that is inherently not true and possibly not correct. And so you're falsifying your output, and I would not recommend that.
It's very tricky.
All right.
Carson,
yeah, go ahead.
Are we wrapping up now?
I was going to wrap up, but if you've got final words of wisdom to impart on us and our listeners.
Well, I guess as final thought, I think the fact that we're actually just having this conversation is progress. I mean, think about, we've been around this business for a long time. I don't think this was something that we would have had, this conversation we would have had, say, 10, 15 years ago.
Oh, yeah. I mean, it was all about efficacy only. Like, can we achieve, a certain efficacy rate? And everyone was just so excited when anything made it into production. But now this stuff's everywhere. And so I feel like as AI practitioners, we have to, really kind of push the conversation and make sure that, we're being ethical, and doing the right thing.
Exactly.
Okay, with that, right before we go, I want to kind of just briefly shout out a couple of organizations that have done some meaningful work in making AI more equitable. The Stanford Computational Policy Lab, which has done a number of projects targeted at reducing racial bias in machine learning. And Sherpa, an organization that investigates how AI can impact human rights and ethics. Bill and Carson, as always, thanks for a fantastic discussion. For any of you who are interested in finding out some more about this topic of AI bias, we do have an article up on Xyonix.com/articles. That's Xyonix.com. Thanks, and we will see you next time. That is all for this episode. I'm Deep Dillon, your host, saying check back soon for your next AI injection. In the meantime, if you need help injecting AI into your business, reach out to us at Xyonix.com. That's Xyonix.com. Whether it's text, audio, video, or other business data, we help all kinds of organizations like yours automatically find and operationalize transformative insights.